appreciate you taking the time to come listen to my talk. Have any of you guys been to the OWASP talk on this before? Because if you have, you probably have already seen it. And can you hear me now? All right. Anyways, I was saying thanks, but if any of you have been out to my OWASP talk, this will be the exact same talk, so you can probably save yourself the time and go watch something else a little more entertaining than this one. But if you haven't, thanks for being here. We're just going to walk through some protocol stuff with HTTP2 real quick. Let me stretch my arm really far. Oh, nice. I feel like I need to straddle this mic. All right, so today we're going to talk about HTTP2. Has any of you guys heard of that protocol before? If you raise your hand, I couldn't see you anyway, so I'm just going to assume you are raising your hand back there. Lots of hands went up, lots and lots of hands. We will talk a little bit about TLS and Perfect Forward Secrecy. The reason for that is because it's a primitive that you need to understand when we talk about some of the other capabilities that work with the protocol. I'll talk to you on how you can maybe look to see if you're using any HTTP2 enabled applications, because you probably are right now if you didn't know it. And then I'll get into my favorite part, and we'll talk about blue team defenses and kind of red team activities. And then I'll wrap it up with a demonstration of a tool I wrote called Merlin. I think some of you guys are dying to know what Merlin is, right, Slade? Yeah. Yeah. Also, I got some free stickers. If you guys want a sticker for the logo for Merlin, come see me afterwards. I got plenty to hand out. That was the way I try to taunt people to come to my talk, was by offering free stuff. Everybody likes free stuff. All right, you can't actually read that still, but anybody want to guess how old HTTP is as a communication protocol? Any of you guys been around when the internet was first invented? Plus, yeah? 20 plus, all right. The very first version of HTTP was version 0.9. Current version is obviously 1.1 and 2.0. 0.9 came out in 1991. Were some of you even born in 1991? No? All right. And then we came up with version 1.0 and 1.1. The thing with HTTP to know is that when it first came out, it was designed to be like a stateless protocol to have communications back with each other. If you were probably using the internet when it kind of first came out, or way back in the day, your web pages weren't that big. You would request something, you'd get something back. HTTP wasn't designed for the things that we use it for today. Most of you are probably pretty familiar with thick web applications, and it's like just using a desktop app, but it's in your browser, leveraging that protocol in the background. So there's a lot going on there on that. And so what happened was Google had decided that HTTP 1.1 is a little too slow for their needs, so they needed a new protocol. And so they decided to come up with HTTP 2. Well, let me back up a second on that. Google had a protocol before that called Speedy. Anybody heard of that one from Google, Speedy? You heard of Speedy? All right. So what pretty much happened is Google was developing a protocol called Speedy, and then someone from the IETF said, hey, we need to turn that into an actual protocol. And they just pretty much adopted Speedy and turned that into HTTP version 2. One of the key things that they had to do with HTTP 2 is make sure that it maintained backwards compatibility. If you notice when you use the HTTP 2 application, the URL stays the same. It's the protocol and the address you're trying to access. Everything has to stay backwards compatible. They didn't want to have to develop new tools and stuff to be able to use that protocol. There are a lot of unique things about HTTP 2 that makes it different than version 1.1. One of them is that the protocol is multiplexed. It means instead of on HTTP 1, it would just send one request and get one response. Send one request, get one response. With multiplex, they can send a bunch of requests at one time and one packet going off. And another key feature of HTTP 2 is that it's bidirectional. Communications can go back and forth like a regular TCP connection. Original web worked on TCP, but it didn't act like a TCP protocol. It didn't maintain a state or a session go back and forth, which is why you have cookies to kind of maintain that state information. But with HTTP 2, you can kind of go bidirectional, go both ways. And then, any of you guys ever done any packet analysis on maybe a web traffic to kind of look at it in Wireshark? Anyone looked at Wireshark and packets? Yeah. And when you open it up and you just follow the HTTP stream, what do you see? You just see the text. You just see the text go through. You can just read it in human readable text format. HTTP 2 is a binary protocol. It's not text. It's not human readable. You can't just open a packet and look at it without a protocol analyzer to go on top of it. So that makes it more of a challenge. It makes it great for traffic going back and forth because it can compress the data down, and it gets rid of vulnerabilities that come with handling packets to figure out where the line terminations are and what the spacing characters and all that kind of stuff are. So HTTP2 is a binary protocol, which makes it drastically different than HTTP 1.1. And then if you guys have looked at web traffic, you'll notice there's usually a stack of headers that go on every web request. With HTTP2, they use another protocol called HPAC, and they do compression on the headers. So it's usually the same data going back and forth on a web request. Usually the same headers are there every time going back and forth, and so HPAC just compresses that down, so it makes the traffic more efficient going back and forth. And I think the biggest one is that HTTP2 has this thing called server push, and a lot of that has to do with head of line blocking. Anybody use like Facebook out there? Anybody? Facebook? Yeah, I don't know. I don't know what it is. When you request that web page, what happens is your web browser says, "Hey, Facebook, give me the Facebook web page," and then it starts asking for all these other files like CSS files and pictures and JavaScript libraries and multimedia and all kinds of other stuff. But each one of those are serial. They happen in one request, and then they get one response, and they can ask for the next one. And if they don't get all the requests, the web page doesn't load. So back in the early days, if you had any frustrations looking at web pages and you're just waiting for it to load, it's probably in the background requesting all those contents. It won't actually display until it gets all the pieces in. And so what that's called is head of line blocking. There's one big thing that's blocking the rest of your web application to download while it's like waiting to load. So with HTTP2, they have this thing called server push promise, and basically the web server says, "I know you're going to need this, so I'm just going to go ahead and send it to you." Because they have that bidirectional TCP connection, it doesn't have to wait for the client to request it. The web server can just say, "I know you're going to need this," and send it off. So that becomes super efficient when you're working with HTTP2. The one thing you do need to know is that in order for that to work, the web application has to be configured that way. It doesn't just work out of the box. You actually have to write the web app to say, "I'm going to push that stuff down." So that comes in handy later on. So earlier I mentioned that HTTP2 needs to maintain backwards compatibility, and kind of one of the quickest ways to do that is if you're talking on an HTTP 1.1 connection and you need to upgrade your connection to a version 2 connection. The protocol is defined, the protocol is called in two different formats, either H2, which you see up there in the upper left-hand corner. H2 stands for HTTP2, and H2C stands for HTTP2 over clear text. Another interesting thing, when Google was developing Speedy, they pretty much said, "Hey, this protocol is going to always be encrypted. We're never not using an unencrypted communication channel like, regular HTTP, if you guys are familiar with that, and you can just read everything in a clear as it goes across the wire." Google's very adamant. They're like, we're not doing any unencrypted stuff. Everything's going to stay encrypted. But they lost the fight against the IETF board on actually standardizing the protocol. The board was like, "Well, what if someone develops a package that can't handle encryption and they want to go back?" So they ultimately lost, and there is actually a clear text version of HTTP2. But I will say that your web browsers won't support it. So Google was like, "Fine, if you're gonna allow that protocol, that's cool, but we're not gonna actually support it in a browser." So your browsers won't actually support HTTP2 over clear text, the H2C communication channel. But if you're using a 1.1 connection and you want to upgrade to a 2.0, this happens on the back end. You don't actually get to choose. What you'll get is HTTP upgrade header, and that will basically tell the web server that you need to upgrade your connection to a new one. And when you do that, what will happen is you'll get back a 101 for switching protocols. But here's kind of one of the neat things about the way the upgrade works. What happens is the web server and the client establish a connection back and forth with each other. And one of the final steps after they finally got HTTP2 going is as one final check to make sure that both pieces can actually talk on the HTTP2 protocol. They send what's called a connection string, a connection preface, or a magic string, which you see right here. And that magic string is the server basically sending the client the letters PRI with a carriage return new line, and the client responds back with the SM, and that affirms that they can actually talk the HTTP protocol. Together that spells PRISM. Anybody remember like an NSA program like inspecting traffic called PRISM? Yeah. So I think that's a play on that. I think someone was trying to basically say we're going to set this protocol up so that it can't be affected by the Prism program, but I thought that was kind of an interesting fact. It spells Prism going on there. So here's just a screenshot, like I was telling you before. You can see the upgrade header, and I have the H2C in there saying what protocol I want to upgrade to. Again, it could be H2 or H2C, or there's actually another header called alt services header that you can use to upgrade to different protocols as well. But this is basically how the web client tells the server that it wants to change to a different one. And then again, you can see down here it's switching protocols with the 101 status message, and it's responding back with the Prism message. TLS. Anybody know what version of the current version of TLS is? 1.3 was actually just ratified about 2 or 3 weeks ago. I was doing a presentation and someone called me out on it, so that's why I know. Well, I had to learn the hard way because someone asked me and I didn't know either, so I thought I'd share that with you. But one of the staples for HTTP 2 to work is TLS 1.2 has to be a thing. TLS 1.1 is not capable of doing HTTP 2. So if you have an old application that can't even support TLS 1.2, you can't use the protocol at all. And TLS 1.2 has an extension called the Application Layer Protocol Negotiation Extension. It's an extension of TLS, and that's what's required to establish an HTTP 2 connection. Earlier I mentioned to you that if a client's currently talking to a web server and it wants to upgrade the connection, then they'll do that. But there are cases when you can actually negotiate HTTP 2 up front without having to do that client server talking to the web server. And you do that through the TLS ALPN protocol. And so what happens, anybody know how a TLS handshake works? Yeah, typically a client sends a client hello message saying, hey, I can talk these CIPHER suites and these protocols, and the server will respond back on it with what they're going to do. This is a screenshot of a client sending a message to a server. So you'll have the TCP handshake, and then you'll have the TLS handshake, and then once all that's done, then they'll start talking actually HTTP 2 at that point. So these things happen ahead before you've actually established a connection with the web server itself talking on the actual protocol. If you notice down here, this client's capable of talking H2, which is HTTP 2, Speedy 3.1, which I mentioned to you. You should probably still see that in some of your web browser traffic. I believe Chrome still supports Speedy. But again, H2 is pretty much the latest version of Speedy. And then you can see at the bottom, my last service that I offer was HTTP 1.1. All right, so I mentioned that TLS is going to be kind of a big part of the game because it offers encryption for the communication protocol. And that's going to come in handy later when I talk about blue team and red team stuff, and it's kind of the premise of why this tool is very effective for me to come up with. But one of the things that that HTTP 2 uses is ephemeral Diffie-Hellman key exchange and elliptic curve Diffie-Hellman key exchange. And what that means is that they have perfect forward secrecy. You guys probably now have a web server and probably have RSA key exchange. Anybody familiar with that? You know, you got that giant private key. Have any of you ever tried to decrypt the HTTP communication? You needed a key to actually decrypt that stuff. Well, with ephemeral key exchanges, there's no key to give anybody. What happens is the client and the server negotiate, they have a pre-master secret, and they use that pre-master secret to make up session keys, and the session keys are what encrypts the traffic going back and forth. If you're using the RSA key exchange method, if someone has the key, they can just go ahead and decrypt any piece of traffic after the fact. So I could capture all your packets now and then wait till 2 months from now when I'm actually able to get that RSA certificate from you, and then I can just go ahead and decrypt it. The RSA certificate is used to develop those session keys, so you can go ahead and read anything. Perfect forward secrecy means that even if you manage to get one set of session keys, that's only good for that session. You have to continually compromise that stuff over and over again. That's why it's called perfect forward secrecy. The actual keying data is never sent across the wire at any point in time. The web server, the protocol specification for HTTP 2 says that if you're not using one of these two CIPHER suites or key exchange methods in your CIPHER suites, that the web browser will actually just send you back an inadequate security message, basically refusing. So all that to say, HTTP2 has to use Perfect Forward Secrecy cipher suites if written correctly. It will not use insecure cipher suites that are not capable of Perfect Forward Secrecy. And let me give you a quick, so the spec for for HTTP2 has like a blacklist of ciphers. Basically, all these cipher suites are blacklisted according to the protocol. Let me show you that real quick. So what I'm showing you here is I'm just going to scroll through, like these are all the blacklisted ciphers according to the specification. All right, so as you guys can see, that was quite a bit of cipher suites going on there. The main thing, again, the main takeaway is that the TLS 1.2 and HTTP version 2 use cipher suites that are good for perfect forward secrecy, and that's again going to play into what I'm about to get to next. I forgot to mention up front that a lot of this work on this protocol was stuff I had to do for a college class that I was taking. And I actually published a paper on kind of some of this stuff a couple years ago. So the work that I did initially is about 2 years old. The actual HTTP2 protocol was actually ratified in 2015, and it's about the time I put the paper out that I had done the work on. When I was doing the work, I kind of checked all the browsers. Again, in a client hello message, which comes from your browser, it says I can talk all these cipher suites. And so I went and enumerated that list that every browser could talk. And then I subtracted out the ones that were blacklisted, and this is what was left. This is about a year or two old, so it's probably changed on the cipher suites, but this is what all the protocols that were left, which is trimmed off the edge of the screen, but that's okay. If you notice, they're all ephemeral Diffie-Hellman exchange or elliptic curve Diffie-Hellman exchange cipher suites. That's all that's left for that. So any of you happen to know if you use HTTP2 right now or not? Like anybody can tell or not? No. So one of the ways you can, if you're using Chrome, you are using HTTP2, by the way. You just probably don't know it. When you talk to Google servers on the background, they're a big proponent of it, obviously. But you can get a little plugin for your browser. The last one that I used had like a little lightning bolt in the thing, so that way it just lights up when you're actually using the HTTP2 protocol, so that way you know. Another thing you can do is look at the web developer console, and it will just say what protocol is being used, so that's another good way to do it. All right, so I was just telling you about how we're using this perfect forward secrecy and that it's hard to break the encryption to read the stuff, especially if you don't have the keying material. And that's kind of the big difference between this protocol, the HTTP2 protocol, is that, again, it uses perfect forward secrecy cipher suites and not RSA key exchange methods where you can just decrypt packets after the fact. Actually, doing packet inspection on an HTTP2 protocol is really challenging. My research had found that typically what WAFs do now, or any type of intercepting proxy that's going to inspect the traffic for TLS, they're pretty much provided with the RSA key, so that way they can decrypt on the fly and keep going. Again, that will not work with this. There is no key to give anybody. The keying material for the session keys never leaves the client or the server. It stays there. So you're like, how would I actually inspect packet traffic on for HTTP2? It's actually pretty challenging. But one thing you can do is if you use an application that has the NSS library is used to compile the application, and they offer an easy way to do that. Most notably, that's Firefox. Firefox is compiled with the NSS library. And so what you end up having to do is you set an environment variable in your Windows or Linux that basically says, write all the session keys to a file, and all those session keys become what you need to actually decrypt the traffic. That works great if you control the endpoint. If you control the workstation and you're using Firefox and you set the global environment variable, then you can have what you need to decrypt the traffic. But chances are you own a web server, but you don't own the client, so you can't control both sides of the communication, which makes it hard. Also for network traffic, you're not going to be able to look at that kind of stuff. So Wireshark is capable of actually looking at HTTP2, so I encourage you, if you get the chance, to go mess around and look at that. By default, if you do it on port 443, Wireshark's going to think that it's HTTP 1.1, so you're going to have to go in and tell it, no, I actually want version 2. And then you're going to have to also tell it where all the session keys are so it can go back through and find the key. I mean, the session keys aren't like just one password or one key. Like it'll be a giant list of lines. For every time it establishes a new connection, it'll have a session key per connection going through. So it'll be quite a lengthy file. And you can go through there and do that. It's neat that Wireshark actually knows how to do the protocol, but my initial work had shown that many other tools aren't actually capable of looking at the protocol whatsoever. So when it comes across their device, they don't know what it is. If you heard me mention it at the beginning of the talk, the protocol is binary. It uses compression and it uses perfect forward secrecy. So chances are, even if you were using a web proxy and you were trying to do some type of inspection, when you see the protocol, you won't know what the hell to do with it anyways because your tooling doesn't understand it. I have seen that tools now are starting to actually come up with protocol analyzers so that way they can actually do a little bit of work with it, but I don't know any practical use cases where that's coming in handy. So again, that helps defeat proxies, reverse proxies. Anybody in here work for a company that uses a TLS inspecting proxy on the way out? Yeah. I'd be interested to talk with you afterward. I actually don't have much experience with it, but I'm trying to find out like what companies do when they do that. First, I know there's the problem of a lot of companies don't want to do TLS inspection at all because then they have to deal with the whole privacy concerns and all that kind of stuff. So some of them just stay away from it completely. But what I'm interested to know is, does your proxy fail open or closed? My general assumption is that it fails open, meaning if you can't inspect it or you don't know what to do with it, you just continue to let the traffic go through anyways. I have yet to talk to someone who says it fails closed and then let me try it on their network to see what actually happens. So it's a little immature in that sense, the tool that I wrote, because I don't know what's actually going to happen. But I would say, by and large part of my experience, most people aren't inspecting traffic at all ever to begin with. But even those that do, I would say probably fail open. And then obviously same thing for a WAF that's going to do the same type of thing, trying to inspect the traffic going back and forth. Snort 3 actually has a HTTP2 protocol analyzer in it. I was trying to talk with one of the Snort guys to figure out how well it worked. My general understanding is that it just looks at clear text protocol and it doesn't do any TLS decryption to actually look at the stuff. My question to the Snort team was going to be, well, how do you actually do the TLS inspection if you don't have the session keys? I'm interested to see how people do that. So those are some of the challenges with packet inspection altogether. All right, so I just kind of like, painted a bad scenario where I'm saying you got this protocol in your network, because you do right now. And I'm like, what are you going to do with it from a security perspective? What kind of controls can you have? There are a couple options. One of them is you can do a protocol downgrade. You can actually set up like a reverse proxy and downgrade a connection from HTTP2 to 1.1. However, by doing that, you're really just ruining all the efficiencies that HTTP2 gave you to begin with. Remember I told you that HTTP2 is bidirectional, stays open connection. You're basically going to say, nah, let's go back to the old way of making things really slow and do that. So it is possible depending on kind of your environment that you're trying to protect, but that is an option to do that. You can do encryption downgrade a couple different ways. If you actually control the server, if you heard me mention earlier, the RFC says that you should blacklist that list of CIPHER suites, but if you actually write the code for the software for the server, you can actually just tell it, I don't care, use it anyways. You control the application at that point. So you could stand up a proxy, an intermediary proxy that allows you to use a weaker protocol, even though the RFC says it's not a good idea. So that way you can have the traffic can still stay encrypted. You can set up some type of like little encryption corridor type thing where like they use a reverse proxy in between two endpoints. It uses a weaker encryption that you can inspect and then put it back up going out is an option. You can also just downgrade the protocol, so you can have an HTTP2 enabled proxy, and then when it comes in on encrypted, you can just relay it back to the server, again using a reverse proxy over the clear text version of the protocol. Again, your support for that's going to be a little challenging. Clients don't support it, but if it's just between a proxy and a web server, you might be able to make that happen. And so during my research, I was looking at, like, what I did was I did a SQL injection attack over the broken web app from OWASP. I did a SQL injection on HTTP2, and it worked. And nothing was able to detect it because it kind of went across that protocol. Nothing could look at it. So what I ended up doing is I used mod security. Anybody familiar with that one? Mod security uses the OWASP core rule sets, one of the things you can use. I've been talking to you like it's hard to inspect the package. You don't have the tools you need to decrypt the protocol. You don't have the encryption keying material to actually inspect it anyways. Well, there is one saving grace. If you use OWASP core rule set on an HTTP2 web server, it actually inspects the traffic at layer 7. So it doesn't matter what level the encryption comes in at. It comes up the stack, and as it comes up the stack and goes off to the actual web server, the encryption is actually removed by that time. So mod security doesn't care if you use an HTTP 3, 4, 10, doesn't care what version you're using. By the time it sees it, it's just processing a request. It can actually tell what's going on at that point. So that's one of my better recommendations if you're fighting off that protocol, you're looking at it, or don't enable the protocol at all. And so I turned around and did the SQL injection attack again with just the web server that could only talk H2, and OWASP core rules that was able to catch it on that protocol, because again, it happens higher up the stack. And then maybe you can't inspect traffic at all. Maybe that's just something you guys are not going to do, which again, I've seen a lot of companies say they don't want to inspect traffic to begin with. You can use another technique called TLS fingerprinting. That connection that happens between the web server and the client, you can fingerprint that because it'll offer a unique set of cipher suites. Not only that, the cipher suites will come in a certain order depending on the tool that it comes from. The applications that it'll advertise, like HTTP 2, HTTP 1, speedy, and all that kind of stuff. So you can use that to generate a hash, and you can use that for fingerprinting traffic going across your network. There's a tool called JA3. I believe it's from Salesforce. That's the tool that does exactly that. It does TLS fingerprinting. It says it can detect malicious traffic just without ever having to inspect the traffic whatsoever. So that's another avenue to look at as well. All right, so all that was kind of like the precursor to what I actually do. Again, I do penetration testing, and I was looking for other avenues to help me out on a test. And I've just told you about a protocol that's new, that a lot of tools aren't capable of understanding, and even if they were capable of understanding it, they're not able to encrypt it, to decrypt it. And I thought to myself, that's perfect. That's exactly what I need at doing a pen test, so that way I can do my job without getting caught. And so what that really helps out with is for evasion. Again, if I'm trying to go through a network, I don't have to worry about a proxy looking at my traffic going back and forth. Even if there was, that thing would be able to actually decrypt it to begin with, so that makes it nice. And then it makes a good actual command and control traffic channel as well, going back across the internet. And you can use that for exfiltration. Again, if you're trying to exfil large amounts of data, if you're in a company that's like trying to protect against that, you might actually be doing TLS inspections so that you can actually see if anyone's exfilling data. But this protocol would make a good candidate for that, to get around that. All right, so finally, we're here. I was going to introduce you guys to Merlin. It is a tool that I wrote to kind of take advantage of all these things. Merlin is a tool that I wrote in Golang. Anybody heard of that programming language before? Yeah. If I haven't told you enough about Google yet, it is another Google programming language. Using Google's protocol, using Google's tools, using Google's programming language and whatnot. And so the way I describe Merlin is a post-exploitation command and control tool. Post-exploitation, meaning the tool doesn't handle the exploit part. You got to handle that part on your own. How you get access to the computer, how you run commands is all up to you. This tool does not do any exploit stuff. It just does post-exploitation activities. The reason I decided to go with Go is because it is cross-platform. Any of you guys use like PowerShell Empire? Problem is it only works in PowerShell. That's the problem. If you compromise anything that's not a Windows box, your shell's not going to work. And you can use Meterpreter as well on other systems that are Windows, and it does have actually pretty good support. But with Go, I can write one code base, and I can just cross-compile it to anything. I don't have to change the code at all. I can compile it for Darwin, which is your Mac. I can compile it for Linux. I can compile it for Windows. I can compile it for MIPS. So anybody know like IoT devices, or ARM, which are cell phones, you can cross-compile to Android, just all in the same code base. So I thought that was pretty attractive reason to use the protocol. I was looking through the protocol list that the language supports. There's another protocol called, or not protocol, there's another operating system called Dragonfly. Anybody heard of that one? Well, it's an operating system, and you can cross-compile this tool to run on Dragonfly if you ever happen to run across it. Solaris, anybody familiar with Solaris? You can cross-compile it to run on Solaris. I actually did it for a little test. It'll run on anything. Raspberry Pis typically run on ARM processors. Cross-compile this to work on that. So it just works on anything, which is why I really like the language. One of the other things I like about Go is you can run it like a script. If you guys have worked with a scripting language like Python, anybody? Python, Ruby, just regular bash scripting, all that. The beauty in those is that when you edit something and you want to run it right now, you don't have to like run it through a dang compiler first and deal with any errors and stuff like that. You can just actually run it. So Go has a feature where you can actually run the program like a script. And the reason why I use air quotes around like is because what's really happening is when you type go run and the name of the thing you want to run, it's secretly compiling it in the background, creating a binary, and then just executing it for you. But it still gives you the perception that you're actually running it like a script. So that makes it really handy if you're trying to do some like live development. You don't want to have to like recompile anything. Merlin comes with pre-compiled binaries. If you guys have used Git, anybody here used Git before, like Git repos? And Go uses something like Git. They use a command called go get, and it goes to the repository and pulls it down. If you're not familiar with that and you try and pull down the Merlin source doing that, you're going to run into a bunch of problems, and it has to do with the way that Go references the libraries. I have had quite a few people put in issue tickets because when they pull down the source and they're trying to work with it, they did it wrong. There is a very unique way you have to do it with Go. I left comments on the GitHub page in case you wanted to do that, but the short and skinny of what I'm trying to say is just download the pre-compiled binaries. It'll save you a lot of time. You don't have to deal with the hassle of all that other kind of stuff. If you actually get into development, you want to mess with it, let me know, and we can work through that. But for the average people, I would say just download the pre-compiled binaries that I provide on the releases tab from Merlin. Do I sign them? No. I could. I don't. No. Yeah. The one thing that I do, which I don't actually give the information out, so that would be useful, is Merlin has a version number and a build number, and what the build number is a hash of the last pull request that it's being compiled against, and that's hard-coded into the actual compiled binary. So you could technically go backwards and check the hash from the last pull request to see what code you're running if you wanted to. But I don't actually, like, the only way you can actually find that string is by running Merlin. You can't, like, I don't put it in a file so you can read it afterwards or anything. And then kind of, why not PowerShell? Like, again, PowerShell was like getting a lot of attention. And I initially actually wanted to write the tool in PowerShell. But the problem is that PowerShell at the time did not support a way for you to configure TLS 1.2. If you remember me telling you, it has to use TLS 1.2. That's the only version of TLS that has support for that ALPN protocol. Today, PowerShell does have support for ALPN, or sorry, does have support for TLS 1.2, but last I checked, it did not have support for the ALPN protocol. So I don't know if there currently is a way. I haven't checked on it in like a year, but that's why I didn't end up using PowerShell, because it just isn't capable of setting the protocol up the way I need to actually do the communication back and forth. So this is a screenshot of the server. Here in a minute, I got actually like a live demo. What's up, Zach? How you doing? So here's a screenshot of the server. I'll walk you through some of the components of the server. I was talking to somebody else who does like tool development, and I was asking them like kind of what are the keys to success on developing a tool. If you want wide adoption, you have to make it easy for people to use. And so that was kind of one of the underlying things I really had to make sure that I put a lot of effort into. And the way I did that is by using tab completion. Like if you're in the middle of typing out a command and you just hit tab, it'll fill out the rest of the command for you. If you are at a blank prompt and you don't know what to do, if you double tab, it'll bring up a list of all the commands that are available to you at that time to be able to use. So I really made sure I put a good effort in there on that tab completion. The server uses, every agent that checks in uses a version 4 UUID string, which are pretty long. I'm not sure if you guys are familiar with that or not. I've had people say that they don't really like having to type out that giant UUID string. You can see that, it's probably hard to see, but you can see that blue colored, all bunch of zeros. That's how long a UUID string is. That's just the empty one, but that's how long it is. And people are like, I don't want to type all those characters out. Give me a way to alias the command. One of my coworkers is actually helping out with a way to alias the commands, but my retort to that is there's tab completion built in. So if you know the first letter of the agent you want to work with, like A, and you push tab and there's no other agents with the A, it'll just fill out the rest of the thing for you. So I would argue that it's just as few keystrokes as renaming the agent to begin with if you're going to use tab completion for calling the agent. Another thing I made sure to do is that everything had a good help menu. So at any point in time you can type help and it'll give you a table of commands that are available to you along with options that you can set for that command. Again, my goal there was that you had everything you need to be able to use a tool. I don't know, have any of you guys ever like been using a tool and like you're trying to get out of it, but you can't figure out the damn command to get out? Yeah, like that's the worst. I was using someone else's command and control channel, and I was like trying to get the agent to die, and I just couldn't find the command. There was no help, exit wasn't working, quit wasn't working. Like, And I didn't just want to kill the program because I didn't want the agent to just keep running on that compromised computer the whole time. So I tried to fight that by putting in a good help menu on here. Command alias was another good thing I tried to put some time into. Any of you guys like big time users of a tool and like just out of muscle memory, like when you get on the tool, like you just type like sessions. Like I just do that personally out of muscle memory. Like I'm on any command and control tool and I'll hit sessions and I'll be like, sorry, that's the wrong command. So for this tool, I try to put alias to like commands that you would run in Interpreter or that you would run in Empire, being one of the the two famous or more popular command and control tools, to try and ease that. So like if you type sessions in Merlin, it'll actually pull it up for you. That wasn't the way that I originally intended for you to be able to get a list, but I put the aliases in there. Merlin has module support. The module support's honestly not that great, but it's better than nothing. It's pretty much described in a JSON file. You can look at the modules. The key thing with the module support is that while Merlin is running, you can actually drop in a JSON file and it will dynamically show up in the list while you're doing it. Some companies have their own tradecraft that they don't want to share with other people, and this is great for that because you can just distribute the JSON files to your team and they can just put them in the directory and it will just show up and use. One of the key things is that you don't have to exit Merlin to be able to use the module. So like you can drop it in there while Merlin's running and you can use it while it's running without having to exit out or recompile or anything like that. So that's really handy. And then another thing, when I'm working on a pen test and I'm done, sometimes I'm like, dang, I was having fun, but I wasn't actually keeping track of what I was doing. So I made sure to put a lot of effort into some verbose logging. Both the server and the agent have pretty verbose log files, so you can go back after the pen test is done. You can read through the file and see kind of what commands you executed with timestamps and what the results were and all that kind of stuff. So you can backtrace your stuff if you need to. And the last one is system commands. Like if you're on a Merlin prompt and you want to, I don't know, do ipconfig for some reason, if you just type ipconfig and push enter, it'll execute it on the system. The logic is if it's not a command that Merlin knows, it'll just turn around and execute it on the actual system you're running it from. I found that to be useful so that way you don't have to exit out of the tool or switch tabs or anything like that. You can just run it there. Right now there's no collision. I haven't had any like a command in Merlin that doesn't go back and forth. And so that was the server component, the agent component. Again, I told you every agent has a unique identifier. It's kind of long on it. When you're running the agent, the precompiled binaries are set to communicate back to the server on the loopback adapter. That's the hard-coded address. That works great for me for testing. It's probably not going to work great for you on a pen test because your server's probably somewhere else, not on the loopback adapter. So there's just a -URL flag you can specify at runtime any other server that you want it to run on. No shell restrictions. I find this to be powerful. Some people don't like it. Typically, you guys all familiar with like cmd.exe or PowerShell.exe or Bash or ZSH. Those are all shells. When Merlin runs, it doesn't run in cmd.exe. It doesn't run in PowerShell. You can specify the shell that you want it to run in. What happens is when you execute a command, it checks the path variable. If the command you want to run is in the path, then it will execute that. So it gives you more flexibility. If you don't want all your commands running in a cmd.exe, you can just specify PowerShell and it'll work that way. So offer some flexibility that way. One way I'm trying to work on evading detection, a lot of tools will do detection based off beaconing. So they'll look at a beacon size for C2 traffic going back and forth. And one of the quick ways to detect beaconing is that it's consistent. Every 30 seconds on the dot, it's a message, a message, a message. And then typically the size of the message is relatively the same every time. And so one way I try and combat that is I have a time skew, so the time will waver so it's not consistent, which is moderately useful. But my bigger win is that I pad a message to every side. So like you can set it on the fly, you can set it while the agent's running, but by default, every time you send a command back and forth, it has your regular command payload, and then it has a pad of somewhere between 2,048 bytes of data going back in there, and it randomly selects that every time so that way it's not consistent. And I do that to try and defeat detecting beaconing. I don't know how well it works, but again, the size is configurable, so you can bump it up to 4096. You can go as far as you want on the size on that. And that goes both ways, from the server to the client and from the client to the server. And so the agent comes in the precompiled binary that you can run on Windows, Mac, whatever you want to run it on. But I also thought to myself, do you guys know what you currently have on you right now that can actually talk to H2 protocol? Your phone. Your phone can talk. If you got a web browser, web browsers can talk HTTP2 as is. So I wrote a quick JavaScript agent that can talk H2 as well. The thing that does suck about it is you're stuck in the context of what JavaScript can execute, so you're not going to be executing system commands unless you have some exploit you're going to run, but you are stuck in the DOM running that. And then last but not least is I have a DLL object that it compiles to. The really cool thing about Go is that I have like 15 lines of code, and that's all I need to generate that DLL, which comes in handy if you're going to run like a run DLL across the network. I've also taken that DLL and embedded it into a PowerShell script so that we can do in-memory execution of Merlin by taking that DLL and base64 encoding and stuffing it into one giant PowerShell script, so that comes in handy as well. The invoke Merlin PowerShell script is most of the work's done by the PowerSploit developers. I just took and shoved the Merlin DLL in there to execute it, but that's on the dev branch for the Git repo as well. This over here is a screenshot of my iPhone. I basically ran Merlin on my iPhone because, again, my iPhone currently has a web browser in it capable of talking H2. There's blog posts if you want to see more on that. Here's a quick demo of kind of the server running. Let me see if I can get it bigger real quick. I kind of put my comments on there so you can read it, so I don't really need to talk while it's going on, but here I'm checking in some agents real quick. There's a list of the agents. So you can see Linux, Windows, Mac. I have an agent running on all those. There's a tab completion for the agents. You just hit tab and go to the one you want. I'll let that keep running. Again, there's verbose commands on there, so you can kind of see what I'm talking about on there. But that's pretty much the end of the talk. I do have another example of the JavaScript agent, which you can pull all of these from my blog on Medium. I'll pull that slide up here when this is done. If you want to know more, I actually have pretty good write-ups. I tried to make sure there's a really good wiki page, that way you're not left confused on how to use it to begin with. Try to make it very verbose on how you can use any of those things. So I guess I'll just turn it over, see if you guys have any questions while this slide plays through. If not, you can catch up with me afterward. Yes, sir? Nice. The gentleman was saying that in Chrome you can go to a console and enable an H2 proxy so you can see the data frames going back and forth, so that'd be pretty handy as well. Again, it's probably like the same thing I was talking about with OWASP. By the time it's gotten to Chrome, all the decryption's already happened, so it's just looking at packets at that point in time that are meant for the browser to obviously understand, so the decryption's already happened. Yes, sir? Yeah, as far as like companies that not in the context of security, yes, I've seen a ton of it. Like Akamai advertises H2. I use DigitalOcean. I recently got an email from them about a month ago talking about how they have support for H2. If we're just talking general server support, yes, I've seen a ton of adoption for H2. Google's been using that for a while. As far as security tools, I have seen an uptick in that as well. I did a quick check about a month ago, and like Imperva WAF is using H2, but they're using one of the techniques that I talked about. I can't remember which one it was. They're either downgrading the traffic to 1.1 or they're downgrading the encryption when it comes back in. One thing I didn't cover too much is if you control the proxy and you set a TLS termination point, then that point the encryption is obviously done because you set a termination point. So that's always an option as well. If you're going to terminate the TLS connection and establish a second one on top of that, that does give you an opportunity. Yes, sir. So I actually wrote Merlin, and it only offers up 2 cipher suites right now. I'm going to go back and make that configurable, but it only offers up 2. I haven't heard about the work on the elliptic curve, but I will say this. No, I'm not worried because most of the times when I'm doing a pen test, nobody even knows I'm there, so I'm good to go. Any other questions? All right, well, thanks for your time, and come see me if you want a sticker. Appreciate it.